Coming to the fourth process domain in our list, that is build preparation. This is a very crucial step in our AM process, because here only we are making sure all our digital files, that is basically a STL file, is perfect for getting it printed, and we make sure based upon a particular technology we provide that particular type of supports, and even orientation and nesting kind of things comes into the picture. And speaking in detail about the fix and edit feature, basically the STL files are made up of triangles, and this particular data when seen in the ASCII file format, it will have 3 different vertex points as one loop, 3 points and one normal. So, by which side this triangle is facing, that particular value will be available for one particular triangle. Same way, particular model is being made using a many number of triangles. When transferring the file, or if the software which is generating the STL file, that means converting the CAD model to STL file, if it is not that much good, then there is a maximum chance that kind of errors can occur. That means a triangle might be missing, so that is also a error, and the triangle will be inverted, that also can be considered as a error. And coming to the next one, that is support generation. Here you can see this particular support generation is feasible for LPBF technology, but when it comes to DLP or SLA kind of technology, it will have multiple pillars, and in the end it will have an angled support. But when it comes to FDM kind of support structures, it might have a tree type of support structure which will hold the model, or it can even have a infill type of support structure which can hold the model. And when it comes to tree type support structure, it will have basically one big tree with multiple branches, and it goes and connects to multiple places of the overhangs. And coming to orientation and nesting, orientation plays an important role, because based upon the orientation only we can consider what is the overhang area, where the overhang is available. So, these kind of things comes into the picture. And nesting is one particular feature which does not work with all the type of technologies, only certain technologies like SLS or MJF, and even with the help of LPBF also we can work with nesting, and VAT photopolymerization also it is possible to do some nesting, but not all the technologies work with nesting. And orientation of a component is very necessary. The reason is different technologies will have different type of strength. Basically when it comes to FFF technology, that is fused filament fabrication technology, where the layers are made like this, and there is a particular property called anisotropy property, and where we might not able to get a better bonding between these two layers. So, if there is a tensile load which is acting like this, then we may get some failure. These kind of things needs to be considered, so for doing the orientation. And all these things are considered as a build preparation step, and there are various softwares available for doing it. And when it comes to fix and edit itself, in the place of Materialise Magics, we have a automatic fix and edit option which does the work in a very easy way rather than taking much of the manpower. And when it comes to support generation, most of the softwares are coming up with automatic support generation. Still we have optimized support generation options coming up newly, and even in the case of Materialise Magics itself, we have E-Stage Metal. E-Stage Metal as a separate plugin which can be installed in the Materialise Magic software, which creates support structure in such a way that in the case of LPBF technology, the metal supports can be easily removed. And when it comes to orientation and nesting, softwares are capable of nesting the components inside the build volume in a very optimized way. And even when it comes to orientation as well, the software is capable of making different orientations and finding out which is the best orientation which will not consider most of the support structure. And even when we give a condition like strength, then that also will be considered, and that will be taken into account. So, these are some of the tools which is available for build preparation, and as I have told you earlier, build preparation will be varying with different technologies. Some softwares listed here works for some of the AM technologies, and some works mainly for any one particular technology only. That means tools like Materialize collaborative AM software platform, 3D Expert, AM Studio, Autodesk who is having the NetFab, who tend to show their presence in the whole AM ecosystem. So, they try to provide their solution for various technologies, that means not only for LPBF, they give it for FFF also, and SLA or DLP, or these kind of technologies are also considered in the picture. But tools like Chitubox, who is mainly into DLP or SLA, and when it comes to Ultimaker Cura, they are mainly for FFF technology, and they only work for that particular technology only. But at the same time they work for any type of machine, and if they are open source, like if the machine manufacturer provides the capability, then this Chitubox or Ultimaker Cura kind of software would able to do the build preparation for any type of machine manufacturers as well. Now coming to very important topic, that is process simulation. Process simulation in additive manufacturing is a powerful tool that predicts and analyzes potential issues like defects and residual stresses during printing, which will help us to ensure higher accuracy and quality in the final part. As I have told you earlier, to set some context, this process simulation tools are mainly used in places where the building cost, that means the printing cost itself is very huge and it is going to take too much of time. In that kind of cases only the process simulation comes into the picture. The reason for that is when it comes to LPBF technology itself, we might be requiring a huge amount of material, and the material cost is also very huge, and machine running cost is also huge. In that kind of scenario, if we are running a print and after some 5 or 6 days if the print fails, then the complete material is wasted, printing time is wasted, and this has to be stopped. So, for that particular purpose only process simulation comes into the picture, where using this kind of software tool we will try to identify the defects, and then where the distortion is happening and wherever the residual stresses are happening. So, these kind of things we will be finding out, and then we will try to eliminate it by making some changes in the process parameters or the orientation or the support structures, so that these defects are carried away. Now coming to defect identification, there are various type of defects available, some things like porosity, cracks and inconsistency during the printing process. These are some of the defects which we can see in LPBF technology. Even when it comes to large format additive manufacturing like DED, or even in the case of FFF itself we have large format additive manufacturing machines. In that also this kind of things comes into the picture. And coming to the second thing, that is distortion detection, that is the geometry is basically going to change here. That means due to immediate heating and cooling of parts in the LPBF technology itself, you can consider that there will be some shrinkages or expansions might be possible during the printing process. So, to overcome this we will try to find out where the distortion is happening, and that will be provided with some distortion compensation also, so that the final part accuracy comes good. And the third one is residual stress detection. Basically in the LPBF technology, due to high level of thermal gradient, will be undergoing residual stresses in the component. Due to this, the part integrity is under stake. So we will try to find out where the residual stresses are higher, and we will find out like whether any heat treatment is required or not. By providing any heat treatment, whether the residual stresses are gone or not. These kind of things can be simulated using these kind of tools. Here you could see various tools available for this process simulation feature, but most of the player are mainly working on LPBF process simulation, then on DED and binder jetting, after which we could see material extrusion based process simulation tools. Hexagon, which already has SIMUFACT. This actually process simulation tool has brought it into its AM Studio platform, which can do process simulation for LPBF and binder jetting. And we have Materialize collaborative AM software platform, which is working with ANSYS for process simulation tool, and it is implemented in CO-AM platform for LPBF technology. 1000 Kelvin, AM SIS, 3D Expert are also working on LPBF technology for process simulation. And here we have AI Build and Helio Additive. They are working on material extrusion based processes like for simulating it, and these are mainly for large format additive manufacturing machines. Now coming to the sixth topic of our process domain, that is build processor. Here we are mainly going to focus on what is the work which is being done in a build processor, and what are the developments in it. And coming to the main work of a build processor, here we can see assign parameter is one of the first and initial step of a build processor. That means it takes up what are the parameters available for making the G code or M code. That means there are various different parameters involved like layer height, print speed, temperature, laser power, gas flow, exposure time, and material type. So these kind of parameters are getting defined inside the build processor, and after that, based upon the layer height, the slicing of the model happens. Here itself in the dog picture itself you can see there are various slices you can see. So this is based upon the layer height which is provided in the assign parameter section, and once this particular layer is getting generated, then after that the tool path for one particular layer is getting generated. That means in each of the technologies, when you consider FFF technology, the print head is going to move along the x and y axis. In the case of LPBF technology, the laser is going to move along the x and y axis. So whatever the technology, the tool path remains the same. So in this kind of cases, we need to create a very optimized tool path so that it generates a very good component finally. And this also considers some parameters like hatch distance or infill density. So these kind of things is getting considered, and the tool path is getting generated. Here itself you can see for each particular layer there is starting point as S1 and ending point as E, and wherever this is mentioned red with green, it is starting or ending point. So this kind of tool path will be generated, and even here also you can see the tool path is getting shifted from one type to the another. In the first layer it is like this, in the second layer the tool path is like this, and again the tool path changes its rotation direction. So this type of things also this build processor takes into the picture. And finally like once the toolpath is generated, that means a type of G code is created. So, once this G code and M code is getting generated in a particular format that is required by the machine manufacturer, that will be transferred to the machine. So, transferring to machine of this G code also comes under build processor only. So, that means the files need to be transferred, and in some cases where in high end machines we need to keep on be monitoring the machine also. So, as similar to build preparation, here also we have like many players available in the build processor domain, who could able to generate the machine code for various technologies and OEMs from a single tool. That means like AM Studio, Cognitive Additive, and 3D Expert, Materialize Collaborative AM platform, and Autodesk NetFab. So, these kind of players will try to provide their support to multiple technologies and multiple OEMs as well. But there are still some players who work with only one particular domain, that is like AMSys, Dintrite, who basically generate final machine code only for LPBF technology for various machines. That means they work with multiple machine manufacturers like EOS or Nikon SLM Solutions, whatever the machine manufacturer it might be, they will work with it. As like AMSys and Dintrite, we have players like Ultimaker Cura, who basically works for FFF technology, and but for any of the machine manufacturer, and Chitubox, who works for a DLP or SLA technology, again they work for any of the machine manufacturer. But here also we have GrabCAD Print Pro, who works only for Stratasys based machines, and that means in their setup itself they might have multiple technologies, for that also they will work. And same way for EOS, they have LPBF technology, and they generate code only for EOS based machines. Now coming to our seventh process domain, that is printing technology and process monitoring. As we have already told, we have discussed more about printing technology in our previous lectures, and we will be seeing more about process monitoring in this lecture. So, when it comes to process monitoring, what are the aspects we need to monitor? So, that is first thing is identifying the defects and anomalies in the real time. When the printing is happening, during that time itself we need to find it out. And the second case is monitoring the key process variables, because certain anomalies or defects we might not able to see it during the process. So, we will find out, we will be keep on be monitoring the key process variables, and finally after testing we can check whether the key process variables are maintained properly or not, or otherwise even if some key process variables are not meeting the required standards, or it is not in a closed loop system, then by monitoring it we can able to improvise it or bring it to the required values. And when it comes to identifying the defects itself, there are multiple sensors being used in LPBF technology to regularly identify any defects are happening in the build platform or not. In the case of LPBF technology itself, we will consider if distortion or blade damage is happening, then immediately a camera could able to detect any anomalies are happening during the building time, and it could able to immediately stop. Not only in LPBF, even in the case of FFF technology, if part is being coming out of the build platform, then it could able to detect that part has been come out and it couldn't able to print it normally. So, we can able to easily identify using a camera with the help of AI, and we can immediately stop the print or rerun the print with the required process variables. Then coming to monitoring, monitoring will work for things like temperature, whether layer thickness is perfect, feed rate is perfect or not, or if these things are going wrong, we can adjust this thing to the optimal manufacturing conditions. Now coming to the tools which are available for this process monitoring, Materialize collaborative AM platform they have recently released its process control module by joining hands with Phase 3D. So, Phase 3D and Materialize, they have actually joined together. Already Phase 3D has got this particular module, and the Materialize collaborative AM platform is actually integrating into their system. And from AdiGuru, anomaly detection module has been released. And when it comes to Nano Dimensions, they have one particular tool called DeepCube. This is built using AI technology, and it is said to detect errors in real time and make corrections as well. And the next player here is AI Build, who basically works on large format additive manufacturing machines, and they have the error detection capability in their software tool. And finally we have EOS, who is actually a OEM, and they have developed one software called Smart Fusion. So, this particular tool it can interact with their machine, that means the EOS machine itself, and do the process monitoring. And we are reaching to the final process domain, that is manufacturing execution system, or we basically call it as MES, which is actually a crucial component in the manufacturing that oversees and manages the production processes as well. And it plays an essential role in facilitating the efficient planning and execution of operations, and it ensures that every aspect of manufacturing process is well coordinated. By integrating functions such as rule based scheduling, material management, quality checklist, and machine performance tracking, this MES can able to optimize this thing like resource utilization and enhance the overall operational efficiency throughout the manufacturing life cycle itself. Now, let us see each of these things in detail. First, we have the planning. Basically, planning will be done before initiation of the project, and here we will be setting up the production timelines, and we will allocate what are the resources required and define the workflow of the project, and will ensure that efficient operation is being done, and all these are for maximizing the throughput in the additive manufacturing. So, all this planning related work is possible to be made in the manufacturing execution system software tool. Then coming to the rule based scheduling. In this one we have a scheduling option where we will set up some rules. We have the facility to set up some rules which can make our workload to be balanced, and so the rules are like predefined criteria which will make us in enhancing the efficiency across multiple manufacturing process. And the third one is material management. Here we will try to manage the materials like our inventories, whether our raw material stock availability, or when it comes to LPBF, even our build platform availability, we need to make sure it has a material management, and if at all some material is getting reduced, we will make sure the timely replenishment of the materials, and which will make sure in ensuring the consistent availability for uninterrupted production. So, a software tool which is actually making sure that planning, rule based scheduling, material management is being concentrated in the same tool itself. And the fourth one, here we have tracking, which comes as project management kind of thing, where we will try to track the project where it is stuck up, or whether any requirements are needed for making the project to flow in a very good manner. So, these kind of things will be done in the tracking. And quality checklist. So, whenever a project is getting initiated, we will make sure that we have a list of quality checklist available, and these things will be made sure that it is available in the MES also, so that digitally we can able to find out whether all the quality standards are met or not. And finally, we have managing the machine downtime. So, managing the machine downtime basically involves monitoring the performance and scheduling the maintenance, so that we can able to minimize the interruption to production and maximizing the overall equipment effectiveness. So, we can see a minimum number of players available in this domain, like people like Materialise collaborative AM software platform, and manufacturing OS is another player who is already providing their service for other manufacturing sectors, but they are again new into the additive manufacturing domain. But whereas we can see Materialise collaborative AM platform who is trying to improvise their AM ecosystem to a very huge level, and we could also see 3DQ who creates 3D printing form management tool, where these type of tools are also required to directly manage the production with a single click. So, with this we are coming to the end of the lecture. Thank you for taking your time to explore the developments in design and process monitoring. We will see you in the next lecture.